Yeah, so the way it works, I showed this to you in live. There can be a parachain. It's assigned like a validator set that gets like shuffled every minute. So that way, nobody can target a specific parachain. So if they were to do it, they have to target the entire Polkadot network. Um, yeah, so because the validator set is shuffled like randomly, you don't know ahead of time which validators are going to validate a specific parachain. So that gives security to these parachains, which is very different from other shared security models. So let's say on Cosmos, like there's no concept of this shared security. You bootstrap your own security for your blockchain. Anyway, so this is so if you are interested further, like you can search for path of parachain block, and that gives you like a really good understanding of how exactly a block is created in a parachain, how it is handed over to the relay chain, how the validators like validate it, and back it inside the relay chain. And yeah, so all that procedure is explained thoroughly there. But I'll give you an overview. So what's the point in holding back when you can understand a technical concept that's very intuitive? So I hope you are introduced to this data structure. It's called a Merkle tree. So the way Merkle tree works is on blockchain. So this is all state, right? So there's accounts like Ben, Kristen, Louise, all of them have like a certain balance. Let's say there's like staking, there's like democracy. So all of this is the state on a particular blockchain. Now, this state, it can be variable in size. So what you could do is you can hash it and you get like fixed size hashes like these. So these fixed size hashes, you again like hash them together, and then you get this hash, and you get a hash at the higher level, and then ultimately you have this state root. Now, if there is no change in the state of the blockchain, the state root hash will remain the same, right? So let's say there's some transaction that happened on the blockchain. So let's say Louis sent Ben like 50 tokens, and then there's something that happened on democracy. Now what happens is you can see that there's a change here, like in Ben's balance and Louis' balance. There's some change in the democracy state, and all the other modules within the state, they remain the same. So their hashes will not be modified. And yeah, so this is the state that has changed. And so think about like a big blockchain network where a lot of state remains like unchanged within a block transition, and very few things change within it. So your goal as a parachain is to send this information. You won't send the entire state information. You send what has changed, and yeah, so and you send the state transition logic as well. So these are the rules of my parachain. These are the transactions that have happened. Please validate, whether these transactions are following the rules that are set by me. So validators do that. They replay all these transactions with the logic of the parachain. And if everything is looking good, they sort of include that in the a certificate saying that this particular block is valid on the parachain. So let's see, there's a question. So is there any size for Polkadot? Yes, so Polkadot has state 2. So we store all this account information on, actually I can show you like at the end of the presentation, what's the current state size of Polkadot. So if you're running like a Polkadot full node, the amount of space it sort of occupies gives you an idea, how much size it's like using.